Hi everyone! Today we are going to see how we can build an indicator to help us pick the best stocks to buy and sell volatility. The first stage is breaking down the vol into identifiable parts. The fair value of the implicit vol is decomposed using hard data and sentiment. The market value is assumed to be the fair value, disturbed only by buying and selling flows. The smart historical vol synthesizes all the information in past and present data, like realized intraday vol over different time spans, spot movements, and more. This is detailed in a separate video. Expected future events include what is yet to happen, but for which we already know that it will have a market impact. For example, earnings publication or clinical trial results. Global market sentiment is an adjustment coefficient used to factor in the market's risk aversion level. Stock-specific sentiment accounts for the context surrounding a company, which may increase the vol in case of uncertainties. Flows impacts are the result of market-limited liquidity in the presence of buying or selling interests. We can gather historical time series for the IV and X which are observable. Our goal is to find epsilon for each stock and day. To achieve this, we will look at each day one by one and perform a simple linear regression to determine alpha, beta, and epsilon. This shows the regression of the stock's implicit vol under smart HV. The regression line in red shows the alpha and beta coefficient. Beta is the slope and alpha the intercept. As seen earlier, alpha and beta can be associated with the global market sentiment on this date, May 11th. Each stock's coordinate gives its smart HV and IV. The regression line gives the expected IV corresponding to the smart HV. This allows us to picture the epsilon of each stock as its vertical distance to the regression line. Let's come back to the financial meaning of epsilon. It is the unexplained part of the IV. The usual cause for it is a buying or selling pressure, but we should always ask ourselves if there is a specific context for the stock which could justify the gap between the expected and actual IV. This task is assigned to the trader using the indicator. In the absence of a specific context, epsilon should tell us if the IV is over or undervalued. We will now test this hypothesis with a second regression over the entire time series. The regressant will be the difference between the IV and the eventual realized volatility. This plot shows a regression of RV minus IV over the epsilon indicator. RV minus IV corresponds approximately to the P&L of a buy and hold option strategy with delta hedge at close daily. As expected, a negative epsilon means a cheap implicit vol, so a positive P&L. We have just found a good indicator of the cheapness of the IV based on historical and static data. We can add others based on IV dynamics, for example. We can also replace the linear regression by more advanced machine learning techniques to look for nonlinear patterns. This is how the CSA indicator is built. Let's see how it compares to a basic indicator. The blue points, corresponding to the CSA indicator, form an elongated ellipse, showing the positive correlation between this indicator and the future P&L of the targeted strategy. No such thing for the basic indicator. In practice, this translates into a prediction that is much further off the mark with a basic indicator than with our CSA indicator. We have shown here how to build an effective indicator of the cheapness of the IV in a buy and hold perspective. Remember, what matters most in machine learning is the quality of the data that you put in. This indicator and many others are computed live and available on the Canari.dev website. Many thanks to A7 Analytics platform for providing the framework of Canari's research. Goodbye.